Hey everyone, today we are back with a video tutorial on ANOVA or analysis of variance. When I first heard about this technique, at one side I was curious, other side I was a little afraid, little frightened. It looked like some methods only to be used by expert mathematicians and statisticians. When I talked with my friends, colleagues and students, I saw that this fear is quite commonplace. So one of the objective of today's tutorial is that we will try to bust this fear factor. Now you might ask me that whether it is justified. So there are so many fears which are not addressed, right? So we try to answer that using the Google search data through Google Trends, which gives you a very beautiful visualization. So basically, these are Google search data about three topics, okay, across quite a large amount of time. One of them represent ANOVA, another clustering analysis, a very popular technique, and another is LSTM, which is a very hot technique for the deep learning, machine learning, and data science community. No prize for guessing that the blue line actually belongs to ANOVA. So you might ask me that why it is like this. The reason is that ANOVA's application is far-reached. So it can be used in engineering, in research, in science, in social science, in commerce, wherever you are dealing with data, ANOVA can come to help you. So we are first going to develop an intuitive understanding of one-way ANOVA. Then we will look at a couple of applications in the context of data science and machine learning. Of course, we are not going to hand compute the results of one-way ANOVA. So the results will be given by some tools, how to interpret that result. And finally, we'll discuss about some of the shortcomings. So let's look at one of the cases where one-way ANOVA is used. So let's say there are three groups of students and for them their IQ has been calculated, intelligent quotient has been calculated. One of the obvious question that comes to our mind is that is there a difference in these groups, okay, in the IQ? So ANOVA tries to answer this particular question. Is there a difference? And as a corollary, if the difference significant. Let's look at another example to understand this better. Here, there are a group of people who are being subjected to four types of diet treatment. Low calorie, low fat, low carbohydrate and control. Okay. Again, what ANOVA will try to find out is that is there a difference in the weight gain or loss among these four types of diets? If there is difference, is the difference significant? Alright. Now, let's try to look at some of the common characteristics of these two problems that we discussed. So, both cases, we were looking at a numerical variable, okay? So, which was in one case IQ, another case, it was the weight gain or loss. And we have one categorical variable. In one case, it was the student discipline, and another case, it was the different diet options. So, these are some characteristics. Also, another characteristics that I want to tell you is that ANOVA assumes that the data is normally distributed. I hope you remember normal distribution, which is your standard bell-shaped curve. And as it assumed this, so this is called as a parametric test. Okay. Now, let's look at how, statistics people formulate the problem. Okay, statistic people formulate the problem on this finding difference. Okay, so let's say we are now focusing on only two groups, and let's say that this first group comes from science students, IQ score of science student, and this is the IQ score of commerce student. Okay, all right. So this can be one case where there is an overlap between these two. Another case can be that there is no overlap between the science student IQ score and the commerce student IQ score. All right. So now the statistics people will call that this is a scenario where there is no significant difference. this no significant difference, they call it as null hypothesis. Okay, and when there is a significant difference, then they call it as alternative hypothesis. So these hypotheses are tested and then you can do some inference. Okay, so these are the hypotheses formally stated. All right. Now let's see how this one-way ANOVA can be used in feature selection. Okay, in case of classification. So let's look at a data first. So this is your very famous and used iris data, which has these 4 independent variables which are numeric: sepal length, sepal width, petal length, and petal width. And this is the class level. Okay. So what I can quickly see is that I have got a categorical variable over here, which can serve as a group to me. So I can take Satosa as a group, I can take versicolor as a group, and I can take Virginica as a group. Okay, and I can find sepal length or any one of them actually for each of the groups. And again, I can use one-way ANOVA to find out whether there is a difference in the value of sepal length across these groups and if that is significant or not. Now, the problem of classification is that if an unknown flower comes, then given the attributes, can we classify them to these 3 classes, any of these 3 classes? So that is the problem of classification. And of course, if I can find out that which of these attributes are significant for this class, the difference is significant, so that attributes will play a more major role. All right. So what we'll do is that we'll set up the null hypothesis that there is no significant difference for sepal length, okay, across the groups, and the alternative hypothesis is the difference is significant. So for all the attributes, I can run one-way ANOVA, okay, and I can select those features for which the null hypothesis is rejected or there is a significant difference between the groups. All right. Okay. So this is called as univariate feature selection. Now you know that actually you need 2 pair of variables, one categorical, one numerical. So naturally this can be used when you are doing a regression problem. So the output is numerical. However, there is a categorical variable involved. Okay, so one such case may be that you are looking at different type of housing estates. Okay, so that can be a flat, that can be a duplex, or that can be an apartment, right? So these are categorical variable. So you would like to see that whether house prices vary among these groups, right? So then also you can apply one-way ANOVA. And if you reject your null hypothesis, then you know that this flat property or this housing property actually plays a role in the housing price prediction. Okay, so this is one case. Let's look at another very common case. Okay, so let's say you have different data sets, okay, and you have found out classification accuracy by which you actually evaluate. So this domain 1 may be your iris data set, and then domain 2 may be your MNIST data set. So different data sets you have got and their classification accuracy you have found out. Okay, so this can be KNN, this can be net based, this can be decision tree. So again, you want to find out that whether the difference is significant or not. Okay, so you can understand that this is also a case where you can apply your one-way ANOVA. Okay, all right. So not only this, you can apply this for comparing different clustering techniques. You can compare different feature selection techniques. So you can actually try different different techniques like PCA, TSNE, LDA, and try to compare them. So any kind of treatment that you go over the data, right? So that you can put here. And this need not be classification accuracy. This could be execution time of the algorithms. Okay, this could be number of reductions that a particular feature selection algorithm is producing. So one categorical variable and one numerical variable. Okay, so this combination is what to be emphasized at. All right. Okay, so now one thing that you might point out is that in earlier case, what was happening that, you remember there were three groups when you looked at science, commerce, and arts, right? So all the students were different. However, here all the data sets were not different, right? So for the same data sets, you are applying different algorithms or different feature selection techniques, right? So this particular type of ANOVA is called as a repeated measure ANOVA, okay? All right, now let's look at the results that different tools produce. So this comes from SPSS, this comes from R, and this comes from Python. All right, so three things I will bring your attention to. One is your degree of freedom, another is your F score, and another is your significance testing. So basically, when you do a hypothesis testing, right, for the significance testing, you need a probability distribution. So for one-way ANOVA, that probability distribution is a F distribution, okay? And basically, when you are trying to find out, so this significance value is actually your p-value. This is also called as p-value. And what is p-value? P-value is actually probability of the null hypothesis being true given the data. Probability of the null hypothesis given the data. Okay, so what do you want? Okay, so if you want to reject the null hypothesis, then this value should be very, very less. Okay, so how much less? That is given as the power of the test, which are also called as significance level, so which is given like 0.05 or 0.01, something like this. So in the first case, if you take a significance value of 0.05, then this value is less than 0.05. So you can reject the null hypothesis. So actually, you do not need to really worry about degree of freedom even. You don't really need to worry about the F score. Only thing for coming to the conclusion is, which is important, is your significance score or the p-value. So this, as I said, comes from SPSS, okay? So this comes from R, and this is the p-value again, okay? And this is also quite less than 0.05. So here also you reject the null. However, in the last case, which is output from a Python package, the p-value is quite high. So in this case, you do not reject the null value. All right? Okay. So now a couple of shortcomings. So ANOVA actually tells that at least one of the pairwise difference is significant, right? So it doesn't tell you that how many are significant. Neither it tells that which one is significant. So for that, Tukey test or HSD test can be done. And as I said, this is a parametric test, okay? So it assumes normality of the data. However, you can use non-parametric alternative. One such very popular technique is called as Friedman test, okay? So I hope you understood something about ANOVA, and if you find the video useful, please like and subscribe. Thank you so much guys for watching.